The Rhine River flowed black and silent through the heart of Europe on the night of March 22nd, 1945, and the men standing watch on its eastern shore had no idea they were about to witness the impossible. General Major Hans Moll stood on the eastern precipice, his boots inches from water that had been Germany's final prayer for survival. Behind him, everything he knew was collapsing. Ahead of him, darkness. And in that darkness, he believed safety. But safety was already an illusion, because on the opposite bank, something was moving in the mist. The Rhine wasn't just a river. It stretched 820 miles of natural defiance. It had stopped the Roman Empire cold. It had carved the boundaries of Charlemagne's dominion. And in every German officer's strategic calculus of spring 1945, it represented the last arguable line between the shrinking Rhine and absolute military annihilation. Moll's engineers had been meticulous. They had vaporized every bridge. They had seeded the western approaches with explosives. They had zeroed artillery on every elevated firing position. They had applied every principle of defensive engineering their storied tradition had perfected over generations. They had calculated that any serious attempt to force a crossing would demand weeks of preparation, mountains of supplies, and casualties so severe that even a fully resourced army would hesitate. But what happens when an army simply refuses to read the same rulebook? What they hadn't factored into their equations, what nobody on the eastern bank had yet grasped, was what was unfolding in those pre-dawn hours on the western shore. American combat engineers were already knee-deep in the current. They weren't assembling a temporary footpath. They weren't launching a cautious reconnaissance. They were constructing a heavy-duty pontoon bridge, a structure engineered to carry Sherman tanks, M10 destroyers, and the unbroken convoy of artillery and ammunition that kept an army alive. They labored in pitch blackness. Artillery shells splashed sporadically around them. The water ran so cold that a man who slipped would lose consciousness in minutes. And they worked with an efficiency that transformed Germany's legendary defensive barrier into something the United States Army treated as almost annoyingly routine, a logistics problem. By the time dawn cracked over Oppenheim, that bridge would stand complete. By the time General Major Moll's command received its first verified reports, George Patton's Third Army would already be established on the eastern bank. Not crossing, already across. The river that Germany had bet everything on had been solved overnight. To understand how this happened, how a nation's final hope evaporated in a single night, you have to understand what Germany looked like in those desperate months. By the winter of 1944 to 1945, the Rhine was being crushed from every compass point. In the east, the Soviet Union's Operation Bag Ration had, during the previous summer, essentially erased Army Group Center from the map. Nearly 25 divisions vanished, the most catastrophic single loss the German military had ever suffered. The Eastern Front lost all coherence. Soviet armored columns poured through the gap like water through a broken dam. By January 1945, Red Army forces were crossing the Oder River and establishing bridgeheads less than 50 miles from Berlin itself. In the west, the story was no less devastating. The Normandy landings of June 1944 had cracked the Atlantic wall wide open. The breakout from the Bocage country in August had shredded Army Group B's defensive structure. Paris fell. Brussels fell. Allied armies raced across France and Belgium at speeds that left German logistics perpetually gasping, always trying to form new defensive lines that were already being outflanked. Germany's final major counterpunch, the Ardennes offensive of December 1944, known to history as the Battle of Bulge, had failed catastrophically. That offensive had consumed irreplaceable fuel reserves, sacrificed elite armored formations, and wasted the last significant strategic reserve the Wehrmacht possessed in the West. By February 1945, Allied armies stood along the Rhine's western bank, along a front stretching from Switzerland to the North Sea. And there they paused, not from weakness, from the sheer reality of what faced them. What makes a river impossible to cross? At its relevant crossing points in 1945, the Rhine spanned between 300 and over 1,000 feet wide. Its spring current ran at 4 to 8 miles per hour, fed by alpine snowmelt, making it fast, unpredictable, and lethal for engineering operations. The eastern bank rose sharply in many places, giving defenders commanding fields of fire over any attempted crossing. And by March 1945, German forces had destroyed every bridge across the Rhine with a single-minded determination that represented perhaps the only operation they had executed flawlessly in the previous 6 months. Every bridge, railway spans, road crossings, pedestrian footbridges, all demolished, all collapsed into the current, all reduced to twisted metal fingers reaching uselessly out of the water. Almost every bridge. Because on March 7, 1945, something happened at a small town called Remagen, roughly 20 miles south of Cologne, that altered every strategic calculation of the war's final weeks. And it happened not through brilliant planning, but through the actions of a 28-year-old lieutenant named Karl Timmerman, a handful of soldiers from the 9th Armored Division, and a German demolition charge that failed. For reasons even German engineers would spend years trying and failing to fully explain, to completely destroy the Ludendorff Railway Bridge before American troops reached it. The Ludendorff Bridge, damaged but still standing, was crossed at a sprint by American infantry on the afternoon of March 7th. Within 24 hours, General Eisenhower had ordered every available division to pour through that bridgehead. The Rhine barrier, Germany's final strategic insurance policy, had been breached. But the story of the Rhine crossings was far from finished. In many ways, it was just beginning, because what followed in the next 2 weeks wasn't one crossing. It was many, and what German forces witnessed in the engineering operation supporting those crossings shook their professional pride far more deeply than any single piece of luck at a partially standing railway bridge. What followed was a full expression of American combat engineering at industrial scale. And it was unlike anything the German military had ever seen, built, or even imagined possible. The crossing that defines this story, the one that made German engineers fall silent when discussing it after the war, didn't happen at Remagen. It happened at Oppenheim. On the night of March 22nd to 23rd, 1945, General George S. Patton, commanding the U.S. Third Army, had been watching Field Marshal Montgomery's preparation for Operation Plunder, the massive set-piece Rhine crossing scheduled for March 24th, with barely concealed contempt. Montgomery's operation was a masterpiece of preparation. 25 divisions, 3,500 artillery pieces, an airborne assault involving 2 full divisions, months of logistical build-up, a plan so thoroughly staff-worked that it consumed entire forests of paper, and the full attention of the Allied command for weeks. By any objective measure, it was a formidable military achievement. Patton wanted none of it. Or rather, Patton wanted to cross the Rhine before it. On the evening of March 22nd, without fanfare, without preliminary bombardment, without months of preparation, Patton ordered the 5th Infantry Division to begin crossing the Rhine at Oppenheim in assault boats. The crossing happened in near silence. Minimal artillery preparation, minimal air support, no airborne component. The 5 TH Division's infantry paddled across the 1,000-foot width of the Rhine in rubber assault boats through the darkness, established a bridgehead on the eastern bank, and reported their success to Patton at approximately 1 a.m. on March 23rd. Patton's response, according to his aide Colonel Charles Codman, was to immediately telephone General Omar Bradley, his Army Group commander, and announce with the particular satisfaction of a man who has been waiting for exactly this moment that the Third Army had crossed the Rhine without losing a single man in the crossing itself, without a set-piece operation, without Montgomery even knowing it was happening. But the infantry crossing in assault boats, impressive as it was, is not the engineering story. So what is? The engineering story began the moment the infantry secured its bridgehead, because what the Army needed next wasn't more men in rubber boats. It needed a bridge. The 998 Treadway Bridge Company and supporting engineer units began construction in the early hours of March 23rd. They worked in darkness, illuminated only by carefully controlled lighting designed to minimize their silhouette to German artillery observers on the eastern heights. They worked in the spring Rhine current, fast, cold, unforgiving. They worked under sporadic artillery fire, and they built a treadway bridge, a bridge designed to carry tanks and heavy vehicles across a major river in approximately 11 hours. Let that number sink in. 11 hours. A bridge across the Rhine River capable of bearing the weight of a 30-ton Sherman tank, built in the dark, by combat engineers working under fire. In 11 hours, Patton drove across it almost immediately. He stopped in the middle, a moment captured in contemporary accounts, and urinated into the Rhine. It was a deliberate theatrical gesture, and it was aimed directly at a specific audience, the German military establishment that had believed the river would hold him for weeks. The German response to the Oppenheim crossing was initially disbelief. Why couldn't they accept what their own reports were telling them? General Johannes Blaskowitz, commanding Army Group H in that sector, received the first report of an American crossing at Oppenheim and questioned their accuracy. It was too fast, too sudden. There had been no preliminary bombardment of the scale he expected, no days of buildup observed by German reconnaissance. The Americans had simply appeared on the eastern bank, and now, within hours, a bridge was reported in place. His staff officers assumed the first reports were exaggerated. They were not. The speed of American engineer operations was not an accident, and it was not magic. It was a product of a system, a doctrine, a training pipeline, an equipment program, an industrial base that had been quietly building toward exactly this capability for years. American combat engineer battalions in the European theater had been trained specifically for river crossing operations of this scale. The training was not theoretical. Engineer soldiers practiced bridge construction repeatedly at speed under simulated fire conditions at dedicated training sites across the continental United States and in England. They were taught to build under pressure. They were timed. They were evaluated not just on whether the bridge was structurally sound, but on how long it took. Because in a river crossing, time was not merely an efficiency metric. Time was lives. Time was the window between a bridgehead holding and a bridgehead being destroyed. And what about the equipment they used? The M2 steel treadway bridge system had been designed with industrial logic at its core. Every component was standardized. Every piece fit every other piece. There were no custom parts, no one-off solutions, no improvised elements requiring a skilled craftsman to shape on site. It was, in the most literal sense, a bridge that could be manufactured in a factory, shipped across an ocean, and assembled by trained soldiers in darkness under fire, because every element of its design had been optimized for exactly that sequence of events. German military engineering, by contrast, operated on different principles. The Wehrmacht's engineer corps, the Pioneer, was skilled, brave, and technically sophisticated. They had performed extraordinary feats throughout the war, bridging rivers under fire on the eastern front, building fortifications in impossible terrain, demolishing infrastructure with precise efficiency. No honest assessment of the war can minimize their competence or their courage, but their system had not been designed around industrial replication. It had been designed around technical mastery. The highly trained specialists who understood the material at a deep level and could improvise solutions in the field. This was an effective model when resources were available and time was not the critical variable. It became a liability when resources were depleted and speed was everything. By March 1945, German engineer battalions were operating at a fraction of their established strength. Equipment had been destroyed or captured. Replacement bridging materials were unavailable. Training pipelines that had never been as industrialized as the American equivalents were now essentially non-functional, consuming manpower the Reich no longer had. The pioneers who remained were doing extraordinary work with almost nothing. The Americans were doing extraordinary work with everything. And the difference was visible in ways that German engineers, professional men who understood exactly what they were looking at, found deeply painful to observe. What did that pain sound like in their own words? Colonel John Thompson, commanding the 1st Engineer Special Brigade, described in his after-action report the sequence at Oppenheim with matter-of-fact precision that reads in retrospect almost like an engineering manual. Equipment arrival, site preparation, anchor establishment, bay construction, completion, each phase timed, each phase executed against a pre-established standard. The report does not contain drama. It contains data. And the data tells a story of an organization so well prepared for exactly this task that the execution of it in the actual event was nearly routine, across the Rhine River, in the dark, under fire. When German engineer officers reviewed American bridge construction reports after the war, in the context of the U.S. Army's systematic debriefing of captured specialists, the accounts that most frequently produced extended silences were not the descriptions of the Remagen bridgehead or the massive Operation Plunder Crossing. They were the accounts of tactical bridges thrown across major water obstacles in time frames that violated the German engineers' professional intuitions about what was physically possible. One captured Hauptmann of engineers, debriefed at a POW processing center in April 1945, reportedly asked his interrogator to repeat the construction time for the Oppenheim treadway bridge 3 times before accepting that he had heard correctly. He then sat for a long moment without speaking. When he finally responded, He did not dispute the number. He simply said in English, "That was better than we were led to believe. We did not know you could do that." What do the numbers actually look like behind these crossings? By March 1945, the U.S. Army Corps of Engineers had accumulated in the European theater an inventory of bridging equipment that represented, in sheer material terms, one of the most impressive logistical achievements of the entire war. The numbers are almost difficult to process in isolation, so they are most usefully understood in comparison. The standard American heavy pontoon bridge, the type used at Oppenheim and at dozens of other crossings throughout the campaign, could be assembled at a rate of approximately 30 to 40 feet per hour by a trained engineer company working at combat tempo. A single engineer company consisted of approximately 200 men. The complete bridge at Oppenheim, spanning roughly 1,000 feet of river, required a work of multiple companies working in coordinated sections. But the system was designed for exactly this parallelization. Multiple teams could work simultaneously on different sections, joining them as they progressed toward the opposite bank. By the end of the Rhine crossing operations in March and early April 1945, American engineer units had built, in the 3rd Army sector alone, over 30 tactical bridges across the Rhine and its tributaries. 30 bridges, in approximately 3 weeks, across rivers that German military doctrine had designated as permanent defensive barriers. The German pioneers of their operational peak in 1940 and 1941 were capable of impressive bridging operations. They had crossed the Meuse and Sedan in May 1940 with a speed that shocked the French command. They had bridged the Dnieper and the Never in the opening years of the Eastern Campaign. But those operations had been conducted with a fully supplied, fully staffed engineer corps operating at maximum capacity, with Germany's industrial base running at full production. What had changed by 1945? The comparison had inverted completely. American engineer battalions entering the Rhine campaign had an average of 14 months of continuous training and operational experience. Many NCOs had participated in river crossing operations in Sicily, Italy, or France before reaching the Rhine. The institutional knowledge was not theoretical. It was practical, accumulated, transferable. When a sergeant explained to a newly assigned private exactly how to position a pontoon bay in a fast current, he was drawing on direct experience of having done it in other fast currents. In other countries, in other darkness, German engineer replacements entering the line in early 1945 had an average of 6 to 8 weeks of total military training. Not 6 to 8 weeks of engineer training. 6 to 8 weeks of everything. Basic soldiering, weapons handling, military customs, and whatever specialist instruction could be compressed into whatever time remained. The depth of expertise that military engineering requires, the understanding of water dynamics, load calculations, anchoring systems, current compensation, cannot be meaningfully transmitted in weeks. It requires months, ideally years. The equipment gap was equally stark. The M2 treadway bridge system that American engineers use at Oppenheim could support loads of up to 25 tons per vehicle. Later upgraded versions supported 40 tons, covering virtually every piece of equipment in the American inventory, including the heaviest tank destroyers. The system had been designed in coordination with the Army's vehicle program, ensuring that bridge capacity matched vehicle weight across the entire force structure. It was a systems engineering achievement, not just a bridge, but a bridge integrated into a broader logistical ecosystem. Germany, by contrast, was operating with bridging equipment that was increasingly improvised. The standard German Brückengerät B had been an effective system at the war's outset, but by 1945, most of the original equipment had been destroyed or captured. Replacement bridging materials were being fabricated from whatever timber and steel was available locally, with load capacities that reflected the improvised nature of their construction. German engineers were building bridges with wood. American engineers were building bridges with precision-manufactured steel components that arrived from factories in Pennsylvania and Ohio via a supply chain that spanned an ocean. And what about the air above them? During American Rhine crossing operations, engineer units worked under an air umbrella that suppressed German artillery observation and interdicted reinforcement routes to the crossing sites. German engineer operations, in the rare instances where they attempted to rebuild or construct defensive bridging, were conducted under constant threat of Allied air attack with no equivalent protection available. The Americans could build in relative safety. The Germans could barely build at all. And then there's a number that perhaps best captures the entire situation. By March 1945, the United States had trained and deployed to the European theater 48 engineer combat battalions, 7 engineer combat groups, 4 engineer construction groups, 3 engineer bridging companies at army level, plus additional specialist units for port construction, railway operation, and obstacle clearing. This was, to use a vocabulary the situation demands, an engineering army embedded within a fighting army. A force of over 200,000 engineer soldiers whose entire purpose was to make geography irrelevant to American operational planning. Germany entered the war with 8 to 6 engineer battalions across all theaters. By 1945, the number that remained functional in the West was a fraction of that, a fraction operating with depleted equipment, compressed training, and no industrial base capable of replacing what had been lost. The math was not a military calculation. It was a verdict. What did that verdict mean for the war's final weeks? The Rhine crossings, and specifically the speed at which American engineers made those crossings operational, did not merely open Germany to invasion. They compressed the timeline of German defeat in ways that had direct consequences for everything that followed. Before Remagen and Oppenheim, German strategic planning for the war's final phase, insofar as coherent planning was still possible, assumed the Rhine would hold for a meaningful period. Long enough for what remained of the Wehrmacht's mobile reserves to reconstitute. Long enough perhaps for political negotiations to produce a separate peace with the Western Allies before Soviet forces reached the Elbe. Long enough at minimum to demonstrate that Germany's final defensive line had cost the Allies weeks of preparation and significant casualties that forcing a defended Rhine crossing should logically have required. None of these calculations survived contact with the reality of American engineering. The Remagen bridgehead, established on March 7th, drew German reserves toward that sector in desperate attempts to eliminate it. Reserves that were then unavailable when Patton crossed at Oppenheim and when Montgomery launched Operation Plunder at Wesel on the night of March 23rd to 24th. The German command, already struggling to maintain coherent defensive operations across a front that had been compressed, fragmented, and repeatedly penetrated, now faced simultaneous Allied bridgeheads at multiple points along the Rhine. The reserves needed to contain one bridgehead were being consumed by another. This is where engineering speed translated directly into operational paralysis for the German command. If each crossing had required days or weeks of American preparation, as German planning assumed, German forces could have used that time to shift reserves, establish new defensive lines east of potential bridgeheads, and at minimum impose meaningful delay. But the American engineer unit's ability to establish operational bridges within hours of the initial infantry crossing meant that armor and artillery were on the eastern bank before German commanders had fully confirmed that infantry had crossed at all. How fast was fast enough to break an army's will? The operational sequence at Oppenheim illustrates this with particular clarity. The 5th Infantry Division's initial assault crossing took place on the night of March 22nd to 23rd. The Treadway Bridge was operational by the afternoon of March 23rd. By March 24th, less than 48 hours after the first rubber assault boat touched the eastern bank, American armor was operating east of the Rhine in sufficient strength to begin offensive operations. The German window for containing the bridgehead, always narrow, had closed before it was fully perceived as having opened. General Patton, who understood exactly what his engineers had accomplished, moved with characteristic speed to exploit it. Within days of the Oppenheim crossing, Third Army units were fanning out across the Frankfurt Plain and driving toward the heart of Germany. The Rhine, which had represented Germany's last credible defensive barrier, had been reduced from a strategic obstacle to a logistical waypoint, a river crossed, bridged, and left behind by an army that hadn't broken stride. Geography stopped being Germany's ally the night American engineers decided a river was just another road. The broader strategic consequences extended beyond the purely military. The speed of the Rhine crossing demonstrated to German political and military leadership, to those still capable of strategic thought in the war's final chaos, that the war's end was not a matter of weeks, but of days. There was no longer a defensible line. There was no longer a geographic feature capable of buying time. What happens when your last argument against surrender is answered in a single night? The Rhine had been that argument, and it had been answered by engineers with steel and ropes and practice hands. Rye Minister Albert Spee, whose responsibilities for German war production gave him perhaps the clearest view of the material reality underlying military operations, described in his post-war memoirs the moment he received confirmation of the American bridge at Oppenheim. He wrote that he understood with finality that no industrial miracle could now change the outcome, because the outcome was no longer a question of industrial capacity. It was a question of geography. And the Americans had just demonstrated that geography was not a question they found difficult. The armies that poured across those bridges did so because engineers refused to accept that a river meant stop. The armies that poured across those Rhine bridges in the final weeks of March and early April 1945, armored divisions, infantry divisions, artillery brigades, supply columns stretching back to the Channel ports, did so because a few thousand engineers had decided in the dark and the cold and the current of the Rhine that a river was a problem with a solution, and that the solution could be built in 11 hours. They were right, and the German army, which had spent 6 years believing that the rivers of Europe were obstacles that protected them, discovered in the spring of 1945 that they only protect you if your enemy hasn't decided years earlier to build an industrial civilization devoted entirely to crossing them. There is a photograph taken at Oppenheim in late March 1945. It shows the Treadway Bridge from above, a thin dark line stretching across the Rhine's gray width, and on it, a column of vehicles moving east. Trucks, tank destroyers, artillery pieces, jeeps, an unbroken line moving steadily across the river that was supposed to be uncrossable. On the eastern bank, the column fans out and disappears into Germany. The photograph does not show the engineers who built the bridge. It never does. Military history celebrates the generals who ordered the crossings. It celebrates the infantry who paddled across in assault boats. It occasionally celebrates the armor that exploited the bridgeheads. What it rarely pauses to celebrate, what it almost never centers in the frame, are the men who made all of it possible. The combat engineers who stewed waist-deep in current through the darkness, handling steel components that weighed hundreds of pounds, building under fire, building on a clock, building with the knowledge that every minute the bridge was not complete was a minute that the infantry on the eastern bank was unsupported. These men were not glamorous. They did not have famous nicknames. They were not the subjects of newspaper profiles. They were specialists in a profession that most people, even most soldiers, find difficult to make romantic. But what they built at Oppenheim, and at Remagen, and at Wesel, and at Worms, and at a dozen other crossing points along the Rhine in those final weeks of March 1945, was not merely a bridge. It was a material expression of a decision that America had made years before the first shot was fired. The decision to treat military engineering not as an art form practiced by gifted specialists, but as a system, a reproducible, trainable, scalable, industrial system that could be taught to ordinary men and executed under extraordinary circumstances. Germany's engineering tradition was deep. It was technically brilliant. It had produced roads and railways and fortifications that stood as monuments to human skill and precision. But it was a tradition built on mastery, on the idea that the hard thing could be done because the expert was present to do it. When the experts ran out, when the equipment was destroyed, when the training pipeline compressed to weeks and the material reserves fell to nothing, the tradition had no floor beneath it. American military engineering had a floor. Why? Because it had been designed with the assumption that the expert would not always be present, that the man doing the work might be a 22-year-old from Ohio who had never seen a major river before basic training, who had built his first pontoon bridge in a lake in Georgia, timed by a sergeant with a stopwatch, told to do it faster, told to do it again in the dark, told to do it again under simulated fire, until the action was not an expression of expertise, but of habit, not art, but repetition. The German engineers who looked at the Oppenheim Bridge in the cold light of March 24, 1945, they were looking at the product of a different civilization's relationship to time, to repetition, to the democratization of technical knowledge. They were looking at what happens when a society decides that the complicated thing should be made simple enough for everyone to do. They understood it in the end. The professional respect was there. You can hear it in the interrogation transcripts, in the careful technical questions, in the long silences before the answers came. But understanding it did not help them, because understanding a bridge after it has already been built is too late. The armies were already across. The war was already over, and the men with the steel and the ropes and the stopwatches were already downstream, looking for the next river. If you made it to the end of this story, drop a comment below. And if you want more deep dives into the hidden forces that shape history, like this video and subscribe to Winds of Thought.